This lesson will be an introduction to parabolas. Now on the screen here, I've got the most basic form of parabola, which takes the rule y equals x squared, as you can see there. Now there's a few key features of parabolas that we need to make a note of. The first key feature is the turning point, often called the vertex. The turning point for this parabola here takes the coordinates 0, 0. So when we talk about the turning point, we always need to label the coordinates of the turning point. The next feature that's important is the fact that in this parabola here, the turning point is a minimum. So some parabolas have a maximum turning point. Ours has a minimum turning point here. The turning point is the lowest point on the graph. The next key feature is the axis of symmetry. Now the axis of symmetry is the equation of the vertical line that goes through the turning point. So the axis of symmetry for this parabola here is x equals 0, axis of symmetry. So it's really important to note that the axis of symmetry is an equation of a line. Here it's x equals 0. It's not just a point, it's actually a line. The final key features of a parabola are the intercepts, so where it hits the x-axis and where it hits the y-axis. So for this parabola here, we've got a y-intercept of 0, so the parabola hits the y-axis at 0, and likewise it has an x-intercept of 0 as well. So those are the key features. We've got the turning point, whether it's a minimum or maximum, the equation of the axis of symmetry, and the x and y intercepts. Now let's have a look at a few different transformations that can be applied to that basic parabola of y equals x squared. The first transformation is related to the dilation of the parabola. Now the dilation simply refers to the width of the parabola. So you can see from these graphs here, this red parabola here is the basic parabola y equals x squared that we looked at before. And you'll notice that with this green parabola, y equals 2x squared, it's become a little bit thinner than that original parabola y equals x squared. So the impact of having that 2 as the coefficient of x squared has made the parabola a little bit thinner, and this coordinate here we can find by just substituting in a point. So if we substitute in x equals 1 into this parabola here, y equals 2x squared, we'll get y is equal to 2 times 1 squared is 2 times 1, which is 2. So this coordinate here is x equals 1, y equals 2. Conversely, this blue parabola here, we've got y equals a half x squared, and you'll notice that this blue parabola, in comparison to the red y equals x squared, the blue parabola is a little bit wider. So the impact of that half in front of the x squared, the coefficient of the x squared, is that it's made the parabola a little bit wider. And again, we can find this coordinate by substituting in the point. So if we substitute in x equals 1 into y equals a half x squared, we'll get y equals a half times 1 squared, which gives us y equal to a half. So we've got the coordinate x equals 1, y equals a half. Now the next transformation we'll look at is reflection. Now the reflection just changes that original parabola that we looked at, y equals x squared, which had a minimum turning point. It changes it to a maximum turning point. So it just flips the parabola. It reflects the parabola. So you can see here, this green parabola here, y equals negative x squared, is a direct reflection of the red one here, y equals x squared, and you'll notice that the impact of the dilation factor still applies in the reflection. So this blue parabola here, y equals minus 2x squared, is a little bit narrower or thinner than the y equals negative x squared, but it's still a maximum turning point. So that's reflection. The last transformation we'll look at is translation. So translation refers to sliding the parabola along the x-axis or up and down the y-axis. So let's just make a note of our original parabola here, y equals x squared, this red one. Firstly, let's have a look at this dark blue parabola here. The rule for that one is y equals x squared plus 2. And hopefully you'll notice the impact of that plus 2 is that it's just shifted the basic parabola up 2 units on the y-axis. So the axis of the turning point of this parabola here will have the coordinates 0, 2 rather than 0, 0. The plus 2 has just shifted it up 2 units. Likewise, with this purple parabola here, y equals x squared minus 3, the impact of that negative 3 is that it's just shifted our basic parabola down 3 units. Notice it hasn't reflected it at all. The x squared is still positive, so it's still going to be a minimum turning point. It's just moved it down 3 units. So that's the translation along the y-axis. In terms of translation along the x-axis, if we first look at this green parabola here, which takes the rule y equals, in brackets, x minus 2 all squared, you'll notice that that has shifted the basic parabola to the right 2 units, which might be a little bit different to what you were originally thinking when you saw the negative 2. You may have been thinking that that moved it in the negative direction 2 units. But this might make it a little bit clearer. If we've got y equals x minus 2 all squared, and let's say we want to find where this parabola touches the x-axis, hopefully you recall that to find where a graph hits the x-axis, we can solve for y equal to 0. Find the x-intercept, y equals 0. So 0 equals x minus 2 all squared. If we square root both sides of this to get rid of this squared here, square root of 0 is 0, so 0 equals x minus 2. If we solve that, we get x equals 2. So that's why when we have x minus 2 all squared, it actually slides to the right 2 units, because you can see from this little bit of algebra that we've just solved that the x-intercept is in fact equal to 2. And we'll talk about that a little bit more in class. But in the same way, this light blue parabola, which takes the rule y equals x plus 3 all squared, shifts to the left 3 units. So even though it's got a plus 3, you may be thinking that will shift it to the right. Shifting along the x-axis will be moving left 3 units. So it's a little bit different to shifting up and down the y-axis, which is possibly a little bit more intuitive. X squared plus 2 bumped it up 2. But we'll talk a little bit more about that in class.